Hi everyone, welcome to lesson 18 of the Advanced Higher Stats course. In this lesson, we will be looking at estimation with bivariate data. You will find this skill on page 33 and 34 of the course spec. By the end of this lesson, you should know the effects of extrapolation, interpolation, and correlation. You should be able to calculate SSR and understand what it means. You should be able to calculate S squared with SSR. You should be able to understand the difference between confidence and prediction intervals. And you should be able to calculate both confidence and prediction intervals. Let's start off with some terminology. Correlation is the strength and direction of a linear relationship between two variables. For example, a positive correlation and a negative correlation. And strong and weak correlations depend on how spread out the plotted observed points are. We looked at this in a previous lesson. Interpolation is when you estimate a value between the highest and lowest data points, and it's more reliable than extrapolation. So, for example, if you estimated a data point here, you would be interpolating because it's between the highest point and the lowest point. And that's more reliable because you know how the trend is. For extrapolation, you're estimating values out with the highest and lowest data point, so it's less reliable. Because when you make the straight line, you know that the straight line between the highest and lowest point is this direction. But what's to say that the line doesn't just curve off here or go up here? We don't know that. So when you're extrapolating, you're assuming the trend is continuous for up to the point you're calculating. And that just may not be true at all. Next, we look at the sum of square residuals, or SSR for short. SSR reflects the extent to which observed values deviate from the predicted values. For example, this means that if the deviation is low, you have a good linear model. You have a good line of best fit, and it accurately or close to accurately predicts values. Whereas if you have a large deviation, it would be the opposite. You would have a large deviation like this one here or this one here, but all throughout the line. So as a result, low SSR means that the linear model is good at predicting values. The lowest can be 0, which is a perfect SSR, and a high SSR is a linear model being bad at predicting values. And you find this, the formula to calculate this, on page 5 of the data booklet. After calculating SSR, we can calculate the sample variance for the residuals in our linear model. And we assume this to be the truth variance. And with that, we can calculate prediction and confidence intervals, and we can predict outcomes. Here's how you'd go around calculating SSR and sigma squared. First thing first, we have to calculate SXX, SYY, and SXY. And before we calculate that, we need sigma x, sigma x squared, sigma y squared, and sigma xy. Now, sigma x is just adding all the x values, which gives us 21. Next is sigma x squared, which is adding all the x values, but you square them first, which gives us 91. Sigma y is adding all the y values, which gives us 45. Sigma y squared is adding all the y values, but squaring them first, which is 375. And for sigma xy, you have to make a new row here. And you have to times both the x values and the y values. And then you add them together, and that gives us 183. Next, we calculate SXX, which is equal to x squared, which is 91, well, sigma x squared, over sigma x all squared over n, which is 6. And that gives us 17.5. Next, let's calculate SYY, which is the same but just y values. So 375 minus 45 squared over 6. And that gives us 37.5. Now last one is sxy, which is 183 minus 21 times 45 over 6. And that gives us 25.5. Okay, after calculating all of that, we have our three values. And now we can calculate SSR. SSR is equal to SYY, which is 37.5, minus SXY squared, which is 25.5 all squared, over SXX, which is 17.5. And that gives me 0.3429. Now, if I want the sample variance, which is S squared, it's SSR over n minus 2, so 0.3429 over 4, and that gives me 0.0857. So that's pretty okay. The SSR is lowish, and the variance isn't too bad. Now, after calculating sample variance, and then taking it as the true variance, we can move on to intervals. But first, we have to know the difference between the two intervals. Prediction intervals are used to estimate a range within a future individual observation would fall into. So what that means is it's used to estimate a range where one singular observation would fall into. So that would have quite a large range. Whereas for confidence intervals, they're used to estimate a range for the average response given by predictor variable x. So it deals with an average, and therefore it will have a shorter range. And you can see that here. For prediction intervals, everything's the same compared to the confidence interval formula, apart from this one plus. And this one plus is there because this is an individual observation. It can have a larger range of values than an average would be. Now let's attempt this question. You have a regression model that predicts students' test scores based on the number of hours they study. A student studied for 5 hours, 2 less than the average time, and you want to predict their actual test score. What is the prediction interval for the student's test score with 95% confidence, given that a model predicts a score of 75, the residual standard deviation is 3, the number of observations is 20, and SXX is 40. So first thing I would do here is I would write out the whole equation, which is y bar plus or minus t s square root of 1 plus 1 over n plus x minus x bar squared over SXX. And then I would fill this in one by one. So the predicted score, or y value, is 75, plus or minus the t value. We need a t value to be in the 0.975 column. So either side is 0.25, 0.025 left, and that would total to 5% if you times that by 2. And then for the v, or the degrees of freedom, it's n minus 2. So we have an n of 20, so it's 18. We go down to 18, and then that column is 2.101. 2.101. Next, we times it by the sample standard deviation, which is 3. Then we times it by 1 plus 1 over n, which is 20, plus x minus x bar, so 5 minus 7. 7 is the average hour studied, and 5 is what our student got, over SXX, which is 40. And then you would just find the range, which is 81.76 and 68.24. So we predicted 75 hours, but it can range from up to 81% and down to 68%, well, roughly. Now let's do a confidence interval question. You are analyzing the relationship between temperature and ice cream sales. For a day with a temperature of 30 degrees Celsius, to more than average, you want to estimate the average ice cream sales with a 90% confidence. What is a 90% confidence interval for the average ice cream sales on a day when the temperature is 30 degrees Celsius? Given that a model predicts sales of 150 units, the residual standard deviation is 5, there are 25 observations and your data set in your data set, and S double X is 100. Again, what I would do here is I would first write out the whole equation, y bar plus or minus t s root 1 over n minus x bar over s double x. And then I would just fill in the variables. So for y, our predicted sales is 150. For t, it's a 90% confidence interval, so we want it to be in this column, 5% on both sides, which will make it 10% left out, so 90% confident. And n minus 2, so we have 25 observations. That would mean it's 23. That means it's 1.714. 1.714 comes up by the residual standard deviation, which is 5 times 1 over n, 25, minus x bar. That's our temperature. So in this situation is 30. On average is 28. All squared over s double x, which is 100. And then we just put that in our calculator, and we get 81.76 as our top limit and 68.24 as our lower limit. And this is a confidence interval question because it asks for the average ice cream sales and not a one-off day. That's the end of the lesson. Now you should know the effects of extrapolation, interpolation, and correlation. You should be able to calculate SSR and understand what it measures. You should be able to calculate sample variance with SSR. You should be able to understand the difference between confidence and prediction intervals, and you should be able to calculate confidence and prediction intervals.